Let's consider another concept, rules for divisibility. When you see a number, having learned these rules, you easily know what and what can divide the number and what cannot divide the number. Let's take the first one, number 2. Any whole number is exactly divisible by 2 if and only if the last digit of the number is even or 0. The last digit of the number is even or 0. In that case, the number will be divisible by 2. Take for instance, 3, 4, 2, 0. This number will be divisible by 2. It will be exactly divisible by 2 because the last digit is 0. Another one is 1, 7, 8, 6. You can see the last digit of this number is even. Because it is even, the number will be exactly divisible by 2. Another one, 3, 4, 0, 8. This number also will be exactly divisible by 2 because the last digit of the number is even. Whenever you see the last digit of a number hence or being even or 0, then that number is exactly divisible by 2. Let's take another one, 3. Any whole number will be exactly divisible by 3 if the sum of the digits of the number is divisible by 3. If the sum of the digits of the number is divisible by 3. Look at this. 3, 4, 7, 1. Look at this number. Let's add up the digits of the number. 3 plus 4, that's 7. 7 plus 7, that's 14. 14 plus 1, that's 15. The sum of the digit of this number is 15. And 15 is divisible, exactly divisible by 3. Definitely this number itself is divisible by 3. Another one, if you have 1, 4, 5, 2. Look at this number very well. Let's add up the digits. 1 plus 4 is 5. 5 plus 5, 10. 10 plus 2, 12. 12 is exactly divisible by 3. Definitely this number 1452 is exactly divisible by 3. Like that. Let's take some example. Example 1. If 24x is a number divisible by 2, if 24x is a number divisible by 2, where x represents a particular digit missing there. If 24x is divisible by 2 and x is less than or equal to 2, find the possible value of x. In this case, all you need to do is consider the divisor. The divisor here is 2. If 24x is divisible by 2, that means before 24x could be divisible by 2, x, that which is the last digit, unknown, must either be 0 or any even number. The x must either be 0 or any even number or digit. But there is a description here that where x is less than or equal to 2, that is, that x we are talking about, that digit we are talking about is either 2 or less than 2. So, what is the possible value of x? X is either equal to 0 or 2. Because of or equal to 2 is possible for it to be 2. So it will be 2, 4, 2. And 2, 4, 2 will be exactly divisible by 2 because it ends in even. The last digit is even in that case. And if it is less than 2, what will be less than 2 that will fit in there? 1 is less than 2. But 1 cannot fit in there because any number that will be exactly divisible by 2 must either be even or 0. So 1 cannot be there. So what can be there is 0. So the answer is 0 or 2. Let's consider another example. Example 2. Example 2. If 37p is exactly divisible by 2 is where p is greater than 2, x is greater than 2, and p is greater than 2, but less than 6. Now let's consider. What could p be? 37p is the number we are considering. What can be the value of p that will make it divisible that will make the number divisible by 2? Yes, where p is greater than 2. Definitely because of that description, p is greater than 2. P cannot be 0. P cannot be 2. So it can only be the next even number after 2, which is 4. Because it cannot be 6. It is said to be less than 6. So you can now see that P is equal to 4. 4 is the only possible value P can assume in that case. And it will be 374, which will be exactly divisible by 2 because the last digit there is 4, which is even. So that is it. Another number we want to consider is 4. Don't forget you've considered 2, you consider 3. Let's consider 4. What numbers will be exactly divisible by 4? Any whole number will be exactly divisible by 4 if the last 2 digits of the number form a number that is divisible by 4. E.g., 1716. Look at 1716. You can see that the last digit of the number forms 16. And 16 is divisible by 4. So that is it. Another number is 3724. You can see that the last 2 digits there is 24, which is exactly divisible by 4. Another one is 1112. See, the last 2 digits there is 12, which is exactly divisible by 4. That is how to know whether 4 can divide a number. If the last 2 digits form a number that is divisible by 4. Let's consider 5. 5. How do you know whether 5 can divide a number? If the number ends with 5 or 0, that is the only condition or the only condition for the number to be exactly divisible by 5. If the number does not end with 5 or 0, then it will not be divisible by 5. But once it ends with 5 or 0, it will be exactly divisible by 5. E.g., example of such is 1325. This number will be exactly divisible by 5. Or 1430. You can see it ends with 0. it will be exactly divisible by 5. Let's see another one. 105. You can see the last digit is 5. It will be exactly divisible by 5. Let's consider another number in the rule of divisibility. Let's consider number 6. For you to know whether 6 can divide into a number, you must know the rule attached to it. Number 6 is a number that combines the characteristic of number 2 and number 3 in divisibility. Don't forget, for a number to be exactly divisible by 2, the last digit of the number must be even or 0. And for a number to be exactly divisible by 3, don't forget, the sum of the digit of the number must be exactly divisible by the 3. So those two characteristics combine into one inside the 6. That is, if a number is going to be exactly divisible by 6, number 1, the last digit of that number must be even. And not all, the sum of the digit of the number must be exactly divisible by 3. So what number is fit to carry that characteristic? Let's test 76356 as a very good example. See, the last digit of this number is even, as you can see. Let's test the addition of the digits, whether it will be exactly divisible by 3. Number 1 condition, the last digit is even. 6 is even. Now, let's add 7 plus 6. That's 13. 13 plus 3. That's 16. 16 plus 5. That is 21. 21 plus 6. That is 27. 27 is exactly divisible by 3. Now that this number has the last digit to be even, and the sum of its digits is exactly divisible by 3, then this number is exactly divisible by 6. That is it. Let's try another one. 223. Let's see whether this number is exactly divisible by 6. 223. Let's use 74 with it, so that it will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It will be like 5 digits, like the first one. So let's see qualification number 1. The last digit is even. Let's see whether the sum of the digits will be exactly divisible by 3. 2 plus 2, that's 4. 4 plus 3 is 7. 7 plus 7, that is 14. 14 plus 4, that is 18. 18 is exactly divisible by 3. 3 can divide 18. That means the whole number is exactly divisible by 6. Let's consider another number, 8. Another number, 8. Any number is exactly divisible by 8 if the last 3 digits of the number form another number that is exactly divisible by 8. That one may be somehow for you. And that is why you must know some numbers that 8 can divide. So if you know to some level, then it will help you to determine even the ones that you may not know because of their size. So, for a number to be exactly divisible by 8, the last 3 digits of the number must form another number that is exactly divisible by 8. Take for instance, 77256. 256 form a number that is exactly divisible by 8. Because of that, we want to believe that 77256 is exactly divisible by 8. That's the rule. You know, 256, the last 3 digits form 256. And 256 is divisible by 8. If you use 8 to divide 256, you see that it goes. It divides it into 32. 8 times 32 will give you 256. That means 77,256 is exactly divisible by 8. Do you understand? Another number is 41,304. 41,304. This number is also exactly divisible by 8. Why? The last three digits, which is 304, is divisible by 8. If you use 8 to divide 304, you get 8 times 38 to give you 304. Take your Bible, try it out. If you use 8 to divide 304, you get 38. And so far, 8 can divide the number formed by the last three digits of this number. That means 8 can divide the whole number 41,304. I want to believe you understand. Let's consider the last two numbers we have. But you will see that we jump 7. 7 is not regular. It's unpredictable. You cannot determine by rule what will be exactly divisible by 7. So it's the only number that you cannot determine. So you can determine for the rest, but for 7, it is irregular. So let's go for the last two digits or numbers we want to consider. Let's consider number 9. For a number to be exactly divisible by 9, you know 9 is a multiple of 3. It will follow the same trend of 3. Remember, if a number is going to be exactly divisible by 3, some of the digits of that number must be exactly divisible by 3. The same way, if a number is going to be exactly divisible by 9, the sum of the digits of the number must be exactly divisible by 9. Let's form an example. 1, 7, 1. You can see 1 plus 7 is 8. 8 plus 1 is 9. The sum of these digits is exactly divisible by 9. Definitely 171 is exactly divisible by 9. Another one, 3, 4, 5. This is, addition of this is 12. Yes, 3 plus 4 is 7. 7 plus 5 is 12. Let's say 12 plus 6, that would be 18. So, since 18 is divisible by 9, definitely 3,456 will be exactly divisible by 9, because the sum of these digits, which is 18, is divisible by 9. Let's do the last one. The last one, 1001008. You can see 1 plus 0 is 1, plus 0 is 1, plus 8 is 9. The sum of all this is 9, is divisible by 9. So 1008 is exactly divisible by 9. This is where we are going to stop on the example of 9, and we consider the last one, which is 10. This is very cheap. For you to know that a number is exactly divisible by 10, it is easy. The number must end with 0. The last digit of the number must be 0. Once you see the last digit of a particular number being 0, then that number is exactly divisible by 10. Example of that abound. 1340, 1270, 750, and so forth. So that is where we are going to draw the curtain on rules for divisibility. Till we meet in the next class. Bye-bye.